Welcome at Ask Professor. I really enjoy your questions, and also here I'm not alone. Here we are in our lab for testing on a scaled V-track, we call it. Nice test rig for the wheel rail conditioning and also the wheel rail contact. I'm not alone. Here's my colleague from IU Group, Railway Engineering. He knows a lot more and he will explain you, all the students, how it works and what we can really measure in this test rig. So keep on track and stay on and read and listen what we have to tell.
My name is Zhen Yang. I'm an assistant professor from the section of Railway Engineering TU Delta. I'm also a teacher for this course C. And now I will show you our V-track test rig. This test rig can help us to measure the coefficient of friction in different wheel contact conditions. So as you asked the question regarding the friction modifier, we can also use this test rig to check how the friction modifier take effect in the wheel contact and what is the performance with different dosages of friction modifier. And for this test rig, we have this beam system to drive the wheel to move, and we have in total 2 motors. This motor, there's one motor, the orange one, and there's another motor. The smaller motor is used to drive the beam to push the wheel to run along the ring track, and that's a big motor is used to apply the torque to the wheel. You can see there's a black shaft that can apply certain torque to the wheel. Then we can simulate different traction conditions or braking conditions. And we can also see that there's a small digital gauge. This is used to measure the angle of attack. So when we change the direction of the orientation of the wheel, there will be some rotation of this road, and the distance from this bar to the meter will be changed. And by measuring this distance, we know the orientation of the wheel. So the speed, the traction condition, also the angle of attack can be well controlled with this V-track system. Then we can, when we run the machine, we can reliably measure the normal loads, the lateral force and the longitudinal force. Then we can derive the coefficient of friction in different situations. In today's measurement, we are measuring the dry clean condition. We can see that there are no leaves or sand or any lubricants on the reel, but sometimes we can apply the third body layers on the reel then to measure the friction level in different situations. Okay, then later I will show you our monitor to how we do once the machine is running, how we monitor the system, monitor all the parameters. And later I will also show you the results obtained from the measurement. Now the machine is running. We can see from this window the glasses, anti-bullet glasses, so that can keep us safe in this room. And we can monitor all the force measured from the machine. This is the longitudinal force, vertical force, and the lateral force. In this measurement, we increase the angle of attack gradually to achieve the friction saturation. So the lateral force is of great interest. That's why we maximize the window of the lateral force. We can see the level of the lateral force now is about 2 kilonewton. Yeah, this green curve is a lateral force, and this normal load. And we can also control the velocity from here. Now the running speed is 16 kilometers per hour, and the torque we applied. Now we're applying a positive torque to simulate the driving, the traction situation, the accelerating situation. The torque applied is 31. This can compensate the negative torque in the gearbox. We actually want to have a 0 longitudinal force. We can see it from here. The longitudinal force is almost 0. Then we can immediately get the data. The data will be transferred to this disk. Then we can analyze the data immediately with a MATLAB code here. And I will show you the results we obtained this morning with this angle of attack test from 0, 0.1, 0.2 to now the pass 1 is 0.6, and the result shown here is till 0.55. We can see that when the angle of attack is increased, the adhesion level, this coefficient of adhesion, this level will go stable. It will not increase anymore because the friction saturation is expected to occur already. We see this obvious stick-slip contact behavior. We see the sudden drops of the curves. From the now we finish the measurement, we can also see from the reels, we can see some corrugation like patterns. They also reflect the stick-slip contact behavior because corrugation is believed to be closely related to the stick-slip contact behavior. Here, maybe with some angles, we can see this corrugation pattern. This was observed this morning, caused by the stick-slip contact behavior. Can we see from here? If we change from that direction, yeah, now we can see it's quite clear.
The first question was about wheel-rail conditioning, where to use and where not, and when it is efficient or not. That's always the question, and that's typical depending on what do you really like to achieve with this maintenance or preventive maintenance actions by lubricating the wheel-rail contact. Like when you see here. We are in the Delft lab, and we like to show also the wheel-rail. This is the real dimensions of it, and you can see the pain, what will give when the rail and the wheel are running to each other, also with high speed. But the question is, when you like to condition this wheel-rail conditioning by a special lubrication or sand, that's depending on what do you like to achieve. When you like to have the lower rolling resistance, then you need to lubricate, like grease. But that's not what we like, because you also need to accelerate, and therefore you need traction. And then you need something else than just lubrication or oil. And therefore we have a friction management idea, so that you could say that's something you can spray on very easy from the train, just inside the real rail contact. And that can be something, a combination of clay, sand, or whatever, to make this happen inside the wheel. And when you talk about management, you control the friction coefficient. That means that you can say, okay, I like a high coefficient, not too high, because then you get cracks because of the wheel rail contact. Also not too low, because then it is slippery track. And that's what we don't like. How can you see it? And what I mean by we don't like, you see that in autumn, for example, like here in Holland at the moment, when you have the leaves and you have a lot of moisture and also water in combination, then within a few passages of trains you have really like a lubrication, really slippery for the wheel, and that's what we have to avoid. So you have two things. You can say, okay, I make this not happening and I clean every time when I drive over with the train to clean it. But cleaning, then you have to clean all of Holland and all the stations, for example. But you can also say I do dedicated parts when we spray on with sand, and that's exactly where you brake or where you accelerate. That's, I think, exactly what you like to hear with this question. Where to use for slippery track? It's around braking and traction sections or areas. And when you talk about, for example, squealing, the noise when you go through a sharp curve or switches, then you need to lubricate the flange. That's this side. And that's exactly why you have to use something else than sand. You need really a grease. And therefore you have to split up the lubrication part of the wheel. So on top you do something else than just on the flange. So when you like to see more, please look at the literature or ask other students how they solve that in their own country. So good luck. So we can go on with the friction question we already discussed in the other question, and that's about when we have this wheel-rail contact. We're standing here in the laboratory of TU Delft Railway Engineering. Then you can say, okay, when we have leaves and I have a lot of moisture or a lot of water, then you get this really slippery third body between wheel and rail. and how to get rid of this. And the best way you can say, okay, how to get rid of it is cleaning the wheel and rail, but that's a lot of work. You can also say, how can I get rid of the leaves? And that's another one. So get rid of the leaves. When I go back in time here in Holland, in 1920, we have small booklets about instructions and regulations, how to handle when you have leaves or forest or whatever, just beside the track. And that says, in the old days, you have to cut all the trees 20 meters on to the left, 20 meters to the right, just make it clean, and you don't have any leaves at all. But that's old days, and that's old school. Also because we have steam engines, and when it is a hot area, for example, and dry because of the summertime, you could also have some sparks and will burn all these leaves and all this forest down. So that's another reason why it was not allowed. But now we live in energy, electric and also diesel, for example. So that's not the case anymore, but the leaves are still there. So how to get rid of the leaves is get rid of them. That's one. If that's not possible, you can manage it by friction management, for example, by sanding or sand gel you can spray on during traction or braking. Or yeah, what else can you do is to make around the wheel there is a lot of turbulence because of driving. So that means normally when a train is running over the ballast, it's like a vacuum cleaner. It sucks everything inside, and then it will landing somewhere, and just where the wheel is, there is the lowest turbulence of all under the train wagon. And that's really stupid, you could say. Eh? Why don't we do something around this wheel so you could have more turbulence or a higher pressure, so you have overpressure, so then you push the leaves what was just going under the train, push away. But then you need some, I don't know, some air wings or other things to install, and that's a long story because it didn't succeed till today, so maybe you can succeed it in your own country. Another question is about wayside monitoring of the wheel profile and also the rail profile. So you always look at the system, that the system makes it's working okay, or it gives a lot of headache. So when you talk about wheel rail as a system and you like to manage this, then the profile are really, really important. And also not because when it is worn away you get some other profiles, that's true, but that's more or less already in the design of the wheel and also in the shape of the rail. So I'm not worried about that. It's more about when you have some flat spots or some bumps or something else inside or imprints in the wheel. That's really dangerous because you get really bad results for your steel. And when some imprints are there or we have some spots, then every circle is bumping on the rail construction, and that's we don't like. When you have only 1 millimeter just on top of the rail, and that's not, that's a really nice shape, for example, and you drive over with 300 kilometers an hour, then you have 300 G extra force because of the bump of the wheel on that spot. And then you imagine what happens, and everything will crack. Even the steel will also deform into like chewing gum. And that's what we don't like. Therefore you need really straight, nice, uniform geometry and no bumps, no flat spots at all. How do we manage that in Holland? We manage these flat spots by systems, wayside monitoring, like we have that Quo Vadis systems, and that's about 40 measurement points in all of Holland. So we measure all of Holland per day continuously, so every train is spot per day, and when they have a flat spot, then immediately a signal will go to the rolling stock owner, and within 48 hours the wheel will be reprofiled and we have a fresh profile because of these problems. And look at the results. You also ask what is the results. We don't have any spring breaks of the primary, secondary springs in the bogie, and that says a lot, I think. So the last question of today is about how to store data and how to use this data, and also when you store data you need energy, and where do you get this energy from? When we, for example, on bridges you can use solar panels or small wind turbines. That's what we do in Holland, for example. But also we do a lot on onboard monitoring of the infra and also the assets. And then you talk about the system inside the train. Then you could say, okay, I have enough power because of the catenary, That's true, but also you can use the brake energy of the train. And that's really a lot. Everybody thinks, okay, braking a train, that's maybe a few kilowatts and that's it. No, it's really a lot. For example, when we have the big city in Holland, Apeldoorn, that has a station, a lot of trains per hour are stopping there because it is a big city. And when we use only the brake power of these trains on that station, we can recharge all batteries for all city buses and taxis for free. So that's a lot of energy. So when you talk about can we save energy inside the trains, yes, we can a lot. Just to recharge your batteries on board when you use this equipment. When you talk about data storage, how much you like to do when you do on board measurements, the best way to do is not to pump all these terabytes to a big computer central in your country. No, when you do it there every day because of onboard, why not do it? Just look at the delta, which is only the information, and put only that information to the central computer, and that makes a lot more efficiency. And you don't break down the full GMSR network like 4 or 5G, what we will get in the future. Even the speed is high, but still it's really time consuming, and it costs a lot of capacity of the mobile network. So make your choice. Thank you very much. I learned a lot also about VTrack of my colleague, how it works, what we can do also in our lab, and isolate parameters really influencing the wheel-rail contact. So hopefully you learned a lot. Next phase is you go to the capstone project, then you have your own case, bring it to us, and we'd like to work with you what you learned in all these courses together to see what can the system be more effective and more profitable for your own case. So let's see, and see you later.